Dear students, in today's session we are going to discuss about inheritance in C++. Before learning inheritance, let us try to understand the main objective of inheritance. The main objective of inheritance is the reusability of the code. Let us see how we can reuse the code which is already existing, which is already written by the developer. See, reusability is one of the important features of C++. Here, reusability allows the user to reuse the existing code. Whenever you have already written the code and if you want to reuse the same code in anywhere in the same program, it is not needed to rewrite the code again and again. Instead of this, we can simply reuse it. That will save the development time and that will also save the effort, that will save the development cost also. So, if we allow the reusability of the code, it will be very nice for a developer. C++ supports the reusability concept by allowing us to create the new classes from the existing classes. So, the main intention of the reusability is allowing us to creating new classes from the existing classes. That is the main objective of the reusability. The main idea behind the inheritance is reusability. See, with the inheritance concept, we can reuse the existing classes without creating the existing classes again and again. We can simply use the existing class and its features. So, let us move on to the main concept, inheritance. Let us define the inheritance. The inheritance is a mechanism of creating new classes from the existing classes. The inheritance allows you to use the existing features of the existing classes without recreation. In simplest way, we can say the inheritance is the process of creating new classes from the existing classes. This allows you to reuse the code. See here, in the inheritance process, the existing class is called as the base class or the parent class, and the derived new class is called as the child class or the derived class or the subclass. If you see this example, here we have an existing class known as the parent class, and from that class we have created a new class called child class. So here, if the parent class contains any members and it has any properties, those can be inherited into child class with the help of this inheritance mechanism. Here we can avoid rewriting the code. So we can simply use the existing code. That is the main objective of inheritance mechanism. See, in this slide, let us discuss how to define the derived class. In the derivation of a new class, we can use this syntax. First, we need to write the class keyword followed by the derived class name, and then we need to write colon operator. The colon is actually the class derivation operator, and followed by visibility mode, and then we can write the base class name. and opening brace and closing brace. Between the opening and closing brace, we can have all the members of the derived class. So, in this syntax, if you see the syntax, the class is the keyword and the derived class name be any valid identifier. The derived class is nothing but any child class name or the subclass name, so which you want to derive it from an existing class. And then we have a colon operator. The colon is a derivation operator. So, to derive this new class from another existing class. And here the visibility mode is, that can be any access modifier. Actually, the visibility mode can be any visibility mode, like we can have the public, private or protected. By default it is private, the visibility mode. If you do not mention the visibility mode, it will be automatically selected as the private mode. And see, this visibility mode actually determines whether the members of the base class should be inherited into this derived class or not. If we have any public derivation, that means we are creating the new class with the public derivation using the visibility mode, that is public, then the base class members will become the public members in the derived class. That is the public visibility. Here the public visibility allows you to access the members of a class outside the class also. That is the main purpose of public visibility. And later on we will try to understand all these visibilities and the different types of derivations. That means public derivation, private derivation and protected derivation. Let us see this example. In this example, we have created a class known as parent class, the parent with some private members and public members. And in the private section, we have a parent ID which is of integer type, and parent name, it is a character type array, that is nothing but a string type. So, these two are the private members. As we already know, the private members are inaccessible outside the class, and these are not inheritable. These are not inheritable into the child class. And we also have the public portion. In this public portion, we have two member functions known as getParentData, which returns nothing, which returns no value. So, because it is void type and it also takes no arguments. And we also have another member function named putParentData. PutParentData is again a void type in the sense that does not return any value, and it also does not take any arguments. That is, the parent class contains some private members and the public members. The private members are not inheritable, and you can see them in the image. See, the private members are not inheritable, and even if you try to access in the child class, they are not inheritable and they are not visible. And see, to derive a new class, see this, here we are creating a child class from the parent, and to derive a new class from an existing class, first we need to write the class keyword followed by the derived class name, and in this case the derived class name is child, and then colon, that is a class derivation operator, and then this is the public derivation. Here a public is a visibility mode, and then we have a parent class name. In this case the parent class name is parent itself, that is a base class. And see, the child class also has its own members. Those members are private and public. Some members are private, child ID and the child name come under the private, and whereas get child data and put child data, these are the two member functions which comes under public section. That means these are the public member functions, and child ID and the child names are private members which are inaccessible outside the class. See, when we derive the child class from the parent class, only the public members, so which are get parent data and put parent data, will automatically inherited into the child class. So, here we no need to define them, we no need to define them in the child class again. That is the main concept of the reusability. Here we no need to write the same code again and again. We can simply use the features of parent class in the child class, and you can see them in the image. The inherited members from the parent class are get parent data and put parent data. They are actually inherited from the parent class itself because they are the public members. They can automatically they can automatically inherited into child class. Apart from this, the inherited members, the child class also has its own members, own member functions, get child data and put child data. They are its own members. See, this example makes you understood, that is how to derive a new class from an existing class. So, in this example we have seen a parent class is an existing class and we have created a new class named child class from the parent class. And here we can show the different types of derivations. See this. So, in the first code, in the first example, we have a private derivation. That means here we are creating a new class named A from the existing class B, but it is a private derivation. It is called as a private derivation. In the private derivation, the members of the base class, will become the private members in the derived class. That is called as a private derivation. And in the second example, class A is derived from class B, but this derivation is public because here the visibility is public. Hence, it is called as a public derivation. In the public derivation, the members of the base class, so in this case the base class is a B and its members are automatically they will become the public members in the derived class. And in the last case, so we haven't mentioned any visibility mode. Even though we are not mentioning any visibility mode, by default it is private. It is a private derivation. That means here the class A is a child class which is derived from the parent class known as B, but we haven't mentioned any visibility mode. So, but it is private by default. That means it is a private derivation. So, these are the different types of derivation. So, let us look at this chart. This chart will clearly show you the derived class visibility and the base class visibility and how the visibilities of the base class will become the visibilities in the derived class. See, in the first case, for example, the base class visibility is private. That means the members of the base class are private, and the derivation is the public derivation. That means the new class is derived in public mode, and we know the private members are never be inherited into the derived class. That means the private members of the base class are not inheritable. So, that means the base class visibility is private and the derivation is public, but the base class private members are not inheritable. That is the first case. And the next case is, if the base class visibility is private and the derivation is done in private mode, that means the visibility is again the private, still the base class private members are not inheritable in the derived class. Next we have the protected derivation. In the protected derivation also, the private members of the base class are not inheritable. So, ultimately we can say that the private members are not inheritable in the derived class. The derivation may be any type, that means that could be the public type or the private type or protected type. The private members of the base class are not inheritable. Next, the base class visibility when it is protected. If the base class visibility is protected and the derivation of the new class is done in the public mode, the protected members of the base class will become the protected in only. The protected members of the base class will become the protected members in the derived class. And the next case is, if the base class visibility is protected and the derivation is done in the private mode, then the protected members of the base class will become the private members in the derived class, because the derivation is private derivation, it automatically changes the protected members into private members. And the next case is, the base class visibility is protected and the derivation is done in the protected mode, then obviously the base class protected members will become the protected members in the derived class, because the derivation is again the protected. Next case is public. In the next case, the base class visibility is the public and the derivation is done in the public mode. Hence, the public class public members, that means the base class public members, will become the public members in the derived class. There is no change. The public members are accessible. The public members are accessible in the derived class because the public derivation allows you to use the base class members because they are the public member. The public members visibility will be public in the derived class itself because the derivation is the public again. Next case is the base class visibility is public and the derivation is done in the private mode. Then the public members of the base class will become automatically the private members in the derived class. That is the another case. Next thing is, in the next case, the base class visibility is public but the derivation is done in the protected mode. See, when the base class members are the public type and the derivation is done in the protected mode, the public members of the base class will become the protected members. So, this chart will give you the clear information how the base class visibility, that means how the members of the base class will become, how the base class members will be changed into derived class and how their visibility will be changed accordingly. See, if you see that example, here we have a class named test and here we have a private section, that is a private visibility, and if you do not mention any private or public or protected, by default the members will be private itself. And next we have protected section. What about the protected section? When we have any protected section, that means the member visibility is the protected. So, those protected members are visible to the functions of its own and as well as the derived class. That means the protected members are accessible only within the same class and as well as in the derived class. Next one is the public visibility. See, when we have the members in the public section, those public members are visible to all the functions in the program. That means not only in the same function same class, they are also available in the derived class. They are visible to all the functions in the program. The functions may be, the member functions may be the same class or they may be the derived class functions. The public members are available to all the functions in the program. So, this chart will give you the complete information about how the visibility of the base class will be changed as changed into another visibility in the derived class. If we see the private visibility is accessible. That means the private visibility is nothing but, so if we have the private members in the base class, they are available only within the same class and they are not at all inheritable into derived class. The private members are invisible outside the class. They are not at all accessible outside the class. That is the first visibility. So, we have already seen it in the chart. Now, protected visibility. What about the protected visibility? In the protected visibility, the protected members of base class are available within the same class. The protected members are available within the same class member functions and as well as they are available, they are accessible to the member functions of derived class. They are available in the derived class member function also. So, when the base class members are protected and the derivation is a public, the protected members of the base class will become protected only. So, we have seen it in the table, the chart. See, when we have any public members and when we have any protected members in the base class and the derivation is done in the public derivation, the protected members will become the protected members in the derived class. There will be no change. And if the derivation is the private, then the protected members of the base class will become the private members in the derived class. That means the private has highest priority, highest domination. That means if the derivation is done in the private, automatically the protected members will become private. And if the derivation is protected, then the protected members of the base class will become protected members in the derived class. That means the base class visibility is protected, and as well as the derivation is also done in the protected mode, then there will be no change. The protected members of the base class will become the protected members in the derived class. Next, let us see about the public visibility. So, the public visibility. So, when the base class members are the public members and the derivation is done in the public mode, then the base class members will become public members in the derived class. There is no change. If the base class members are public and the derivation is also public, then the public members of the base class will be public in the derived class. And if the base class members are public and the derivation is private, then the public members of the base class will become the private members in the derived class, because it is a private derivation. And so once they are inherited into the derived class, they will become the private members. That is the second case. Next, when we talk about the public visibility, and if the base class members are the public and the derivation is done in the protected mode, the public members of the base class will become automatically the protected members. And we already knew about the protected members. The protected members are accessible by the member function of the same class, and they are also accessible by the derived class member functions. This image will give you the clear understanding, that makes you clear understanding about this visibility. Here we have a class named B, and it has some private members, protected members and public members. And as we have already seen, the private members are not at all inheritable. They are not at all inheritable into the derived class. And if you see the protected members, see this here, class D1 and the D2 are actually derived from the class B. And in the first case, class D1 is derived from the class B in the public mode, that is, it's a public derivation. And in this case, the protected members of the class B is nothing but the base class here. The class B protected members will become the protected members in the class D1, because it is a public derivation. The protected members of the class B are the protected members of the class D1. There is no change. And the next thing is, just look at the right side here. So on the right side, the class D2, that means we are deriving a new class D2 that is derived from the class named B, but its derivation, the derivation is the private derivation. See, the class D2 is derived from the class B, but the derivation is a private derivation. And so in this derivation, the public members of the class B will become automatically the private members in the class D2, because it's a private derivation. The public members of the class B are automatically they will become the private members in the class D2, because it is a private derivation. And when we see the protected members of the class B are automatically changing into private, because it is a private derivation, the protected members are automatically converted into private. So because of the private derivation, that is the second case. And in the third case, you can see, in the third case, we are deriving a new class named class X, and it is derived from both the classes D1 and the D2. It is actually a multiple inheritance. We will discuss about in the next few minutes. See, in the here class X is a new class. We are deriving it from two classes D1 and D2. And see, first we are deriving the class X from D1 in the public derivation mode, and the class X is also derived from D2, but it is derived in which mode? Protected mode. And in this case, the D1 members, so the D1 members, see, if you see, there are private, protected and public members. The public members of the D1 they will automatically become the public members of the D1 automatically become the public members in the class X, because it is a public derivation. Next, the class D1 also has the protected members. These protected members, because of the public derivation, so they will become the protected members in the class X, because it is a public derivation. Next, see, the class X is also derived from another class named D2, but this derivation is a protected derivation. So, because of the protected derivation, let us see how this visibility changed from the base class to derived class. See, here its parent class is the D2, here the parent class is D2. See, the D2 has some protected members and the public members, and here the protected members automatically become the protected members in the class X, because it is a protected derivation. And next, the class D2 also has the public members, and the public members of the class D2 are automatically converted into the protected, because it is a protected derivation. So, this image make you understood about the complete visibilities and the complete types of derivations: private derivation, public derivation and protected derivation. And let us see the forms of inheritance, that means types of inheritance. See, the inheritance can be in these 5 types. This can be of 5 types: single inheritance, multiple inheritance, hierarchical inheritance, multi-level inheritance, and as well as we also have hybrid inheritance. So, let us see one by one. The first category is single inheritance. In the single inheritance, a new class is derived from only one another existing class. That means there will be only one base class for one derived class. So, when one child is derived from only one parent, that is said to be a single inheritance. So, if you observe here, B is a derived class and it is derived from class A, and here class A is called as a base class or the parent class, and the class B is called as a subclass or the child class. So, if you see this, here there is only one parent for one child. Here the class B is actually derived from class A, that means a single class is derived from single base class. So, that is why it is called as a single inheritance. In the single inheritance, the members of this base class are automatically inherited into the derived class if the availability is there. That means if the members of the base class or the public members are protected members, they are automatically inherited into the child class. So, that is single inheritance. In the single inheritance, only one class is derived from one another existing class, that is called as the single inheritance. So, here we have a sample code. So, that lets you understand how the single inheritance can be written. See this, in this example we have included one header file, that is #include IO stream. Next, we are also using one namespace named std, and next I have one base class. The base class name is base itself and it has protected member. The protected member is int b, so it is a data member. And next we also created some member functions, get and show. The get void get, it takes one integer type argument, and that argument will be assigned to this member function, a member variable, data member. And next we also have show b. Show b is a member function, so that actually shows the b value. So, that means the base class has one protected member and the public member. And next we are deriving a new class. The derived class name is, that means the new class I want to derive is the derived. Okay, so it is going to be derived from the base class named base itself, and this derivation is a public derivation. So, because we are creating a new class from only one existing class, this is going to be a single inheritance. It is going to be single inheritance. And see, apart from the inherited members, see, when we derive a new class from an existing class, automatically these public members, what are the public member functions here? Get b and show b, they will automatically they will automatically inherit it into derived class. Apart from its own member functions, getD and the showD, it also gets what? Some member functions, that means the public member functions from its parent. Its parent is the base class actually. And in the main method, we are creating an object of derived. So the derived DER, here the DER is nothing but an object name. So this is an object of what type? Derived type. DER dot getB, we are invoking getB method. So it is accessible because this derived object can access the public members of which class? Its base class. Its base class member function is getB. We are invoking that function and also passing one argument. So we are accessing one inherited member function of base class. Next, dir.getD, it will access another member, its own member function, that is getD. So getD is its own member function. It is also accessible because it is a public member function. Next, we also have der.showB. Der.showB, so we are invoking it base class member function. So showB is again a public member function, so it is accessible. Next, der.showD, we are invoking showD member function, which is actually a member function of the derived class. So that means we are inheriting the base class public members into public and protected members into derived class. Thank you.